The Mechatronics and Robotics Research Group is presently involved in advanced manufacturing research. We are currently exploring how humans and robots can work together in a manufacturing system. The idea is that robots do not replace humans in manufacturing environments, but rather remove the mundane tasks that they are currently involved with, making the manufacturing environment safer and more friendly towards humans, but still keeping the human involvement, thereby preserving jobs and upskilling people. A further thrust of our research group is the innovation and development of low-cost robotics for the South African market and also the African market at large. The National Research Foundation is presently funding much of our research into the development of unique robotic architectures.
In 1995, the Mechatronics and Robotics Research Group was formed, commonly known as MR2G. The purpose of the group was to provide solutions to local industry, also to provide human capacity development for master's and PhD students and undergrad projects as well. Now the purpose as well was to make sure that we have research that is cutting edge, and that's why we strongly invite our undergrad students to become involved in projects at final year level and then move through the postgrad and PhD level. Exciting projects, mobile robots, kinematic robots which you see behind me, advanced manufacturing systems, mechatronics. These are the cutting edge projects that are making up the fourth industrial revolution as we speak. The group has evolved over the years and has produced over 100 master's students, over 50 PhD students, conference papers and journal papers. It is really amazing how members of the group are spread throughout the world, and it just shows how in demand our graduates are. So I encourage all students, prospecting students, to have a look at our research group, have a look at our projects, and come and join us in an exciting venture of mechatronics, robotics, and advanced manufacturing systems.
The research areas of MR2G are robotic mechanisms and applications. This has to do with serial, parallel, and hybrid kinematic robots. The second part of research that we are interested in are machine and robotic monitoring. This is to do with maintenance and predictive maintenance, health diagnostics, and condition monitoring. The third component is advanced manufacturing. The scope for this are cyber-physical systems, robotic automation, and operations optimization. The fourth component are additive manufacturing. This has fundamental approaches in 3D and 4D printing. This includes printers like FDM, SLS, SLA, DLP, and SLM. And the last component are automated guided robotics, which have to do with robotic guidance systems, UAVs, AGVs, and so forth.
Next we move on to supervisors. So you as a master's student will be required to complete your project under the supervision of one of our academics. Now for the Mechatronics, Robotics and Research Group, those academics are Prof. Bright, Dr. Padiachi, Mr. Athelweb, Mr. Bason, Mr. Dharmalingam, and myself, Ingrid Botha. So you can take a moment to pause the video and have a look at our specializations that's shown on the screen and see if any of these strike your interest. So over and above the specialization and whether this is within your area of interest, another thing to consider with your supervisor is if they have the same outlook in terms of what their expectations of the masters are for you. And a great way to determine this is to first schedule a series of meetings prior to you starting the application process. And what this allows you to do is you can meet up with the supervisor, you can discuss your expectations, what your plans are career-wise after the masters, and see if that aligns with one, their research field, and two, their expectations and scope of the project. And over and above this helping you understand exactly what's expected of you, it also builds a rapport between yourself and your prospective supervisor. So starting off with the design in front of me, I have a serial robot arm that was used in a paraplegic archery device. We have a plastic injection molding machine, a security robot, a CNC router, a 3D Delta printer, as well as another type of serial robot arm. And these are just a few examples along with the ones that are shown on the slide, which is a refreshable Braille reading device which translates printed text into Braille in real time. More on the manufacturing side of things, we have a human-robot collaboration system which allows the robot, through a series of sensors, to generate its own position relative to the human working around it for safety reasons. We have a sensory glove which allows a human to control a serial robot from a distance away. So for example, a surgeon who can be performing a surgery from across the country using the glove and the arm. And then from a more mobile robot perspective, we have drone technology and drone artificial intelligence, where on the slide you'll see a 3D printed vertical takeoff and landing device. And these are only a few examples of the possible master's projects that we've completed in MR2G.
For those of you wishing to pursue a career in academia, working to develop the cutting-edge technologies of the future, a master's degree is the vital first step in developing your research skills. And for those of you going into industry, a master's degree is not just a method of separating yourself from the pack in a competitive job environment, it can also be an expectation in a number of career fields. When developing your career in academia or industry, a master's degree is a key way to develop your own skills in the areas of research and problem solving in such fields as robotics and manufacturing, for example, developing programming, simulation and design, as well as your own personal skills such as problem solving, as well as other fields of personal growth.
By the time you register for a master's degree with the Mechatronics and Robotics Research Group, you are already a graduate engineer. And therefore, when students come into postgraduate studies, we expect that people who sign up with us would display the type of professionalism and work ethic that is expected from type of individual that has a bachelor's degree in mechanical engineering. In other words, the type of work ethic that we expect you to display would be that displayed in the workplace as if you are undertaking your first year of work. So what does this mean? This means coming to the office on time, being accountable to your supervisor, being conscientious about the way that you conduct your work. And so, in a nutshell, we expect our students to display the highest level of professionalism, and you should treat your master's research project in the same way that you would treat your first job opportunity. Our history has shown that students who do not approach this type of a project with the correct work ethic often deregister from the degree and tend to waste a year of their lives. So when you come into the Mechatronics and Robotics Research Group, we expect you to handle the pursuit of this degree with the utmost dedication and seriousness.
Welcome to the MR2G postgraduate office. Within this office space, we have dedicated workspaces and desktop PCs that are available for each postgraduate student. All relevant software is available for postgraduate students. If a unique software is required, you can arrange this through your supervisor. The MR2G office also has a kitchenette. This office is also fully air conditioned and we can accommodate up to 14 students in this office. MR2G has its own dedicated laboratory for experimental research. Within this laboratory, we have various types of equipment such as Fanuc robot serial arms, we have a Festo MPS manufacturing station, we also have a CNC lathe, programmable routers, and many more. Behind me, as you can see, are the dedicated workstations that postgraduates have full access to. Within this laboratory, and by using the workstations, the postgraduates also can use the tools and materials available to them. Some of these tools include soldering irons, electronic components, mechanical components, and vice grips, and many more. During my time as a master's student in MR2G, I personally worked in this lab to build and develop my prototype for research work. I can definitely vouch and say that this lab significantly helped me with my progress for my master's research work.
Mechanical engineering at the University of KwaZulu-Natal. We design, we engineer, we power. Mechanical engineering combines sound knowledge of physical and engineering science with ingenuity to create mechanical devices and systems that are essential in almost every industry and every phase of technology.
The University of KwaZulu-Natal prides itself in being a research-led institution, and the Mechatronics and Robotics Research Group is a proud contributor to this effort. Over the years, we've produced exciting research in the field of robotics, mechatronics, and advanced manufacturing. Exciting projects have involved the design and development of CNC machines, robotic manipulators, and manufacturing simulations in our laboratory. The quality of research that we produce is of utmost importance to us as we aim to make a contribution to the engineering and scientific community. We also want our research to be impactful to South African society. So where am I going with all of this? We want our research to be publishable, and not only publishable but also scientifically peer-reviewed in high-quality journals and conferences. It is therefore our expectation that when master's or PhD graduates join our team, that you will share in our enthusiasm to make a powerful contribution to the field through the format of writing up your work and putting it out into the scientific domain, where it will be reviewed by our fellow academics and published in high-impact journals, therefore placing your work in a domain where others can look at it and glean from your work in order to advance their research efforts.